Kole ngambulo luku. We do. Jioni safu no la. With whatever we do. Hale yi demu school. Nyepamne ne kudlukula. Nyepangira lagena. Nyepamne ne kudlukula. Ibulo beti sola. Ibulo kenda to ni betoto.
Bigi Congo.
Jibe norin te nyame lamin
Kama na ulo kono.
Muna ngata afongole
Haina.
ngata ngoto le Fabrama
Mingi.
ngoto le Fabrama Dumala mu ndele bare muso
Jamani mbele.
Alindo ko. Ari ngoto man kontande.
Bari jamani fana na ramudu wa kontan.
Ngoto minaka ngala min de fon filitala lami jibe.
Ida siran sama ne benki. Yala so tol sayni no ko mo lokko momo.
Ngoto.
Naam.
Lamin hakilo diata bake karambu ngoto. Anu ministry ko di ngole si suwo ko amake ko do holiday la.
Si bitu.
Bagona ringa.
Ala ni ku kede namo balo ba.
Ala ni na ko na cartable be damla ala ni je.
Ngoto.
Naam.
Ngoto man kontan fere.
Jamani mu nekata.
Ngoto fuyte malo lamin nyande sila la be la moy kala karango.
Jamani karamol be sorande ne ko fasita wulo kono ko.
Karambugol ma soron ni ko karambugol soron da amake comme holiday lem. Ngoto. Dini ngo nyande sila la ala karango la moy yamen kamen fuwe. Man kontaan
Allah nyin kombo courant adan dal kombo len do la jan karam mol soron do kamen courant ma dal lo kombo e don dol fana na karam mol soron amina dara lo nyino la ala mu nekela
am lamin ite foyde malon ko lesinol be ke kar radio to
Nga fine.
e ko nyina di mod lamin ya mu na fonye
bir kabin mina kan tambita eri maning fatu
ha
tambite la sugal ala dinngol bebe siri be la moy ka
faru dan so am fana tambira jele ni subala la ngaje dinni kili waro e be serin jele
dante ku kili woke no la ba lamin bi taka wulo ko no nyin taymo alami
amandara fenela
ite dide ko ni man si yakari lesinol la moy radio to balon na
mu ne ka ke afonye ba nyaara ni alon
telentel jikot
afonye ba mu ne be ke
ite balon tel be jikritel rambe ku kele yaje nata karana mbasa malaya ay tarije
par ñarande kombo courant ho findira kombo ide na raje den sonka ba ko lamin manya tala wulo ko aru karam mo be so dafa nyambe kala
ko to wole nati bawo ngalle ni lamin kunta kombo courant o ka fa me kombo courant aso total wala kinay ko e si suwo kono ibe karangol di ke la radio lin telel to ani tele masoto to nyaay man tele soto da bongo ba radio be bulen koto batiri sanga ay si ay alamu
sa do kala
nyaadi ko ta o bulaji
abe kala nyaadi
kamun ke nyaadi
radio abe wala mo la ibe mona falaje
ibe la karandirol kala jele
ti talle be radio
le sobetro baby jele ibe
anga chocho moy fa dan so wolya ngombe tambi kana ngadi ningol jebe ikadum bungo ko kada mama mo
asotalde
lamin mala be kana wala de
Lafta alal ideal on ko inde every year second wala fourth.
muna ni ko nde ko folle sinila ba ndele sinilo ne ba
mba say mba foke en koto wole fango yen wulindi yalo famo keta bat ñu fanam bulata tati jambi lamin nyanta karana ndel be bulo kana tambalo yo be bulaje en koto dindi ngoy si ayala le sino la moy radio
wara ka munda karamo man soro lamin nyanda kara si suwa
radio la silale ayala le sino
ndale ko korna ko smalo e bin ko momo say bi do abaro sa no radio ba bari woro radio ni abe jele bari
yo
people on the grade 4, 5 and 6, and today we are going to a new theme in mathematics, which is algebra. On the algebra we are going to discuss simple algebraic expressions. We'll go on adding like terms. So rest assured that this lesson is going to be fun. As we said earlier, the topic on the discussion today is algebra, and algebra is a theme, it's too broad. Now we are looking at the mango as in its spelling. Now let's decide not to use full spelling, and we take only the first letter, which is M. So if you have 1M plus 1M is equal to what? 2m. Remember, the m here represents mango. So one mango is equal to 2 mangoes. What this thing is simply, m can be used to represent mango. It's just like when I say plus 1, it is equal to 2. 1 plus is equal to 2. So here it's 1m, that is 1 mango, plus 1 mango is 2 mangoes. That is 1m plus 1m is equal to 2m. So we can use letters to represent numbers, to replace numbers in expressions. Similarly, we can have the same results for A or B or C. We can always use letters, numbers in expressions. Like if you look at these other ones, is A, just letter A. How many A's are here? There is only one A. So we can say is equal to A. We have here. Now, how about if you have two A's? This A here can mean an apple. How about if you have two now? You have A, another. What will that give you? How many A's do we have? Here is one A plus another A. So how many A's? Plus A plus what? A. And that's what we have. If you're able to add A and A together, because they are the same, don't worry, we'll come to talk more about those things. You can do it for having, assume the A is an apple, or it can be anything. It can be a phone, iPhone, it can be any other phone. So long you send something, and here if we assume that A represents apple, then A plus A will give, if you have A plus A plus, how many A's are we adding? 1, 2, 3. We are adding A plus A will give us 2A plus another A. So A plus A is going to give us 3A. You can add 4 A's, 5, 6 A's. All you need to know is, are you adding? And other letter, it can be Y plus Y plus Y plus Y plus. Now be very observant. All what we are adding are all the same. They are all Y's. How many? We have 1, 2, 3, 4. We are adding. So the answer to Y plus Y plus Y plus Y is going to give 5. So you can use any letters. If you want, you can use Q and so on. But when you add them together, it's going to give you the number of those letters that you're adding. Next slide. So let's move forward. This slide, we're going to talk about terms and like terms. we're going to talk about terms and like terms. On the terms here, when we reflect back to the previous slide, we were talking about plus A, and we said A to 2A. Now, we want to center the discussion on the terms. What are terms? In this context, we have A plus A is equal to A. In this equation, we have how many terms? We have A is a term of, and 2A is a term of its own. How are terms when we are given expressions or equations? Are created expression or when separated by either positive or an equality sign. These are the three signs separate terms in an expression or an equation, right? Let's only talk about expressions. So along the lesson, you may be seeing addition and subtraction. More so, the lesson is about addition. We'll be seeing a lot of additions. So how do we identify terms? Is when we have an expression that is separated by the addition sign. So for instance, when I have 2A plus A, expression, how many terms are here? If you we have 2A and A, but something is in the middle. What is in the middle is the addition sign. Conclude that there are two terms here. 2A is its own, and positive A is a term of its own. So in this expression, there are two terms. I would like to bring something else. Let's say we are adding a lot of A's plus A plus A. Let's say this is the expression we are given. Looking at it, adding 4 A's. What is in between these A's are addition signs. So each and every one of those A's is a term of its own. They are all positive. So similarly, we can have 2x plus y. What do we see? We have 2x plus y. We are talking about A's. So don't only think when the variable is weighted. No. The variables can be different of terms. Now in this expression, 2x plus y, how many terms are there? Addition is in x and y. So 2x its own, y is a term of its own. So in the expression 2x plus y, there are terms also, they have like terms. Let's look at like terms, and then we will build up as to what are unlike terms. The definition of like terms that we have on the board here reads, like terms are terms that have the same variable. Like terms are terms that have the same variable. Like for instance, and terms. When you have 3x and only x, these are like terms. 3x and x are like terms. The term 3x has a variable x, and the term x also has a variable x. These two terms have something in common. And what do they have in common? They have the letter x in common. So that is why they are like terms. Let's look at, and we will be what are the like terms. For instance, when I have the expression a plus 3b plus an a b. Let's try to identify the like terms. If you can remember, terms are separated in an expression by addition sign. I understand that. So we can say 2a is a term of its own, positive 3b is its own, a is a term of its own, and b is a term of its own. So what are the like terms here? Following the definition, that like terms are terms that the same variable. The variable we are referring to as the unknown, referring to as the variables. So a, b, that is 2a plus 3b plus a plus b. If you look at it, 2a is having the same variable with the term a. The term 2a is having the same variable with the term a. The variable there, the variable is a. So we can say 2a and a are like terms. That is 2a, a. Those ones are like terms. So we are able to add an they are like terms. We are able to add 8 like terms. For that, when you have two a's, another a, you put them together, how many a's will you have? Let's say this a represents someone whose name is Amadou. You have two people who bears the name Amadou right here, and you have another person who bears the name Amadou. Add them up, they have. How many people will you have that bear the name Amadou? The two that you have plus the one that you bring in is going to give you how much? 1, 2, 3 of them. So the same idea is what we are trying to do here. And we want to add. This is only possible because variables are the same, because the two terms are like. So we can go forward to add this to be 2a plus a to give us 3a. But don't worry, we'll do more of that in the lesson. Let's try to spot out the other terms here. The like terms in this expression. Like terms when the variable is a. So do we have other when the variable is b? The answer to that question is yes, because if there is a term that is 3b, another term that is b. So the variable 3b is b, and the variable in the term b is b. So b and b are the same variable, so the two like. So to 3b plus b, we'll be able to add 3b. They are like terms. Let's say the b represents banana. 3 bananas plus a banana, how much will it give you? There you can add them, not two bananas. So 3 bananas rather, plus a banana will give us 4 bananas. That is going to give us B. So we are going to concentrate on like terms. So expressions that have different terms, what we are going to do is we are going to spot out all the like terms, put them together, then that is going to be the lesson. So now we look at these expressions. Given to us, it simplify the following expressions, and we have 2 of them here. We have 3y plus y plus y, and the second one we have 6p plus 3p. Let's start with the first one. 3 plus y. First of all, let's try to examine whether they are like the expression. How many terms? We have 1, 2, 3. 3y is a term of its own, plus y is a term of its own, and the other plus y is also expression 3y plus y plus y. There are, let's to see if they are like terms. We define like terms as terms that have the same variable we have in the term. In the 3 terms that we have, in every term, if you observe, you will see that there is a variable y. So we can conclude that all the terms in this expression are like terms. So we are asked to simplify, and the operation is addition. Let's go ahead and do that. I'm going to use some long method of doing that. Y plus y plus y. Just like in the case of A plus A, we said this 3a. Now instead of the question giving us A plus A plus A, we are given 3a. So what is A adding itself 3 times? So when we have 3y also, it means y adding 3. So y will give us y plus, that is, then here we have plus y, that is the second term, plus y. Then the third term is also plus y. We have it down, we have plus y. So in total, how many y's are we adding? We have y plus y plus y plus y plus y. How many y's are we adding? 1, 2, 3, 4, 5. So when we add y 5 times, it's going to give us y. Well, this could have been done in another way, and shortly I will show you. This y plus y, we could just add the other y's. 3y will give us, if you have 4 y's and you add another y there, it will give us 5 y's. So that gives us the answer, 5y. So later on in adding like terms, we may not be opening the 3y, or we are given 2y. 3 plus here is 1y. The reason why you're not seeing 1 there is because y is just y. But the number of y there is more than 1, the number will be given to you. That is why here, y's that we have here is more than 1. There are 3 of them. That is why you have 3y. I hope that is clear. So 3y plus a y plus another y will give us 5. Let's look at the second example. In the second example, we have p plus 3p plus 2p. 6p, 3p plus 2p. In this expression, how many terms do we have there? If you look at it, we have 3 terms. 6p is a term of its own, 3p of its own, and 2p is a term of its own, following the definition of a term. Again, we look at whether all the terms are like terms, which among them are like terms. Let's look at the variable. What variable? The variable in the first. Let's look at the second term, that is 3p. The variable in the second term is equally p. Then we look at the last one, that is the last term, 2p rather. The variable in the last term is also p. We said the variable is the letter that is used to replace the number. So here we have 6p plus 3p plus 2. All the terms have a common variable. P is common in all. So this simply tells us that we can add them together. So in doing so, we are going to add plus 3 plus 2. That will give us the total number of p's that we have. 6p plus 3p. If you have 6 p's and you add 3 p's to it, that's going to give us 7p, 9p. Then you add p on. I'll add p and 3p together. 6p plus 3p will give us 9p plus the one that we left behind was 2p. Let's break it down. 2p. So 9 plus will give us 11p. So if we add 6p plus 3p plus, our answer is going to give us 11p. Remember, the reason why I bracket is because I want us to confine ourselves into adding only 6p and 3p. We are all so you can add 6p plus 3p, which is going to give you 9p. Then 9p plus 2p is going to give you 11p. All like this, you solve them step by step. Now we look at this other set of examples. Simplify the expressions below. The expressions that we have 3a plus d c 2d. Example is 2 plus 3a plus 4. Let's look at the first example, which is 3c plus 2c plus 2d. In this expression, how many terms do we have here? We said addition or subtraction separate terms in an expression. So we have a lot of terms here by the addition. We have 1, 2, 3, 4. 3c is a term of its own. D is its own. 2c is a term of its own. And 2d is a term of its own. Our objective in this case is to collect the like and add them together. So if you look at it, in order to spot out the like terms, we said they must have this. We have in this expression, there are 2. We have c as a variable and d as a variable. Terms that have the variable c, we are going to put them together. And all the terms that have the variable d, we are also going to put them together. So this is going to give us, the first term here is 3c, the second term is d, the third term is 2c rather, the last term or the fourth term is 2d. So you can see the terms that have the variable c, 3c and 2c. So we can have those ones grouped together as 3, 2c. We are putting because they are like terms. Then we continue adding. Then we look at the other variable, that is d. If 3c and 2 are like terms, let's find out if d and 2d are also like terms. They will be like terms when they have the same variable. Well, as you can see, they are variable. D is a common variable in both terms. So 2d are like terms. So we're going to have, after having 3c plus 2c, we are going to have plus d plus 2d. See, we've created another expression, but here only we only arrange the like terms together. C and 2c are like terms, and d plus 2d are also like terms. Then we move ahead to adding the like terms. 3c will give us 5c plus the other like terms are d and 2d. D plus 2d will give us what? D, and it will have going to give us. So when we add the first two like terms, that is 3c and 2c, you have 5. Other two like terms, that is d and 2d, we have 3d. Can we add 5c and 3d? The answer is no. Why? Because the two terms are unlike terms. The variables are different. The first term has a variable of c, and the second term, which is 3d, has a variable d. So here is where we can stop in. If you observe, when I add 3c and 2c, the answer is 5c. I wrote 5c instead of writing c. Some of you may be thinking, are we writing first? How it's, you cannot write the variable. You go to higher level, this number has its, it will be given to you when the due time. But right now, what I want you to understand, you cannot write the variable before the number. So just like any other example, you cannot write B2. The correct way to write that is then you bring the variable. Let's move on to the second example. The second example reads 12b plus 3 plus 4b. This expression, how many terms do we have there? We have 3 terms. 12b is a term of its own, 3a is a term of its own, b is its own. Is simplify to add the like terms. We know there are 3 terms. Let's go ahead to find whether all the terms are like terms or 1 or 2 out of them are unlike terms. Let's look at the expression. Plus 4b. How many do we have there? A is a variable and B is a variable. So we are going to look at the terms that have one of the variable, and those terms will be referred to as the like terms there. As a variable of b, that is 12b, The second term has a variable of a, that is 3a, and the third term has a variable of b, that is 4b. So in this case, you can see that 12b and 4b are the variable. b terms. So we're going to put them together. So this is going to give us 12b plus 4b. What is the other term? Plus 3a. Does 3a have any other like term here? No. There is no other term that has a except 3a. But b has a like term. That is 12b and 4b are like terms. So we can put them together. This is going to give us 12b plus 4b is to 16. You have birds. You have 12 and f can give you 4 birds. Now in total, how many birds would you have? 12 plus 4 is going to give you. So when you add 12b plus 4b, the answer is going to give us 6. Then is 3a. That is plus 3a. You have 16b plus 3a. Can we add these two terms? No, add the two terms because they have different variables. The first term, which is 16, variable of b, this 3a has a variable of a. So this is where we can stop in terms of simplified expression. So if we simplify the expression 12b plus 3b, is going to be 16b plus 3a. That does it for that question. We move on. Here we have some questions that we want. You try the questions at home, and when you come back in the next lesson, we are going to do the corrections of this. I will read the questions out. The first one, we have 6x plus 2y plus 5x plus 3y. 6x plus 2y plus 3. The first expression, what you are asked to do is to simplify it just like the way we are doing the other ones. Collect the like terms and add the like terms. Don't add the unlike terms because they have different variables. Question in the try questions is 10d plus 7r plus d plus r. 10d plus 7r plus d plus r. So in this case also, identify how many terms you have, collect the like terms and add up the like terms. For today's lesson, thank you for listening. We'll meet next time to continue on algebra in our subsequent lessons. So thank you.